Hey guys, this is going to be the 7-6 notes and the 7-6 part 2 notes, and as I said before, you're going to need to do the homework problems, and they're due tonight by midnight. Okay, so here we go, 7-6 double angle in half angle formulas, right? So remember how we were talking about sine of 2 theta, how that was, we did some trigonometric equations with that. Well, think about it. Isn't the sine of 2 theta equal to the sine of theta plus theta? And so we just did the sum of sines. So if I follow that formula, this would be my alpha, this would be my beta. This would equal the sine of alpha times the cosine of beta plus the cosine of alpha times the sine of beta, right? Which would be the sine of theta times the cosine of theta plus the cosine of theta times the sine of theta, all right? Now that's like terms that I can add together, and I just get 2 sine theta cosine theta, okay? This is actually kind of a, hold on, it's a formula right there. The sine of 2 theta is equal to 2 sine theta cosine theta, okay? All right. Likewise, I can figure out the cosine of 2 theta, okay? Again, it's the cosine of theta plus theta. Let's write down the formula for cosine, sum of cosine. It's the cosine of theta times the cosine, or sorry, it's the cosine of alpha times the cosine of beta minus the sine of alpha, sine of beta. That's just the formula for sum of cosine. Okay, again, in this case, this is my alpha, this is my beta. So this is going to equal the cosine of alpha times the cosine of, sorry, not alpha, theta. Cosine of theta times the cosine of theta minus the sine of theta times the sine of theta, which is equal to the cosine squared of theta minus the sine squared of theta. Again, this is a formula. Now, there are 2 other variations of the double cosine formula, but I usually think the cosine squared minus sine squared really is the one that I'm going to use most likely. Okay, so if I wanted to find the sine of 2 theta in this first example here, and I know that the sine of theta is equal to 3 over 5, and I know that I am in the part of the unit circle from pi over 2 to pi, which of course, what quadrant is that? That is quadrant 2. Okay, so I need to draw a triangle in quadrant 2. So here I go, drawing my triangle in quadrant 2. Okay, I know the sine is 3 over 5, right? Sine is 3 over 5, sine is y over x, so the y is 3. My radius is 5. Okay, I can see that this is a Pythagorean triple. My x is going to be -4. Make sure you remember it's a negative because you're going to the left. So if I follow that first formula for double sine, I know it's going to equal 2 sine theta cosine theta. I already know that sine of theta is 3/5, and now that I just drew my triangle and I figured out that the cosine of theta is x over r, which is -4 over 5. Okay, so I'm going to multiply that by -4 over 5, and I get 2 times 3 times -4, that's -24, over 5 times 5, which is 25. Okay? Moving on. If I wanted to know what the cosine of 2 theta is, well, I already have this information up here. I already know that the sine of theta is equal to 3 over 5. And we just figured out that the cosine of theta is equal to -4 over 5, right? So I can use that information to find the cosine of 2 theta by using this formula, cosine squared of theta minus the sine squared of theta, which is equal to, well, I know that that's going to be -4 over 5, that whole quantity squared, minus 3 over 5 squared. All right, -4 over 5 squared is just -4 over 5 times -4 over 5, which is equal to 16 over 25, minus 3 over 5 times 3 over 5, which is 9 over 25. And 16 minus 9 is 7 over 25, and that's my answer. Okay? All right. We want to establish this identity for the tangent in terms of tangent. So here we go. If I wanted to find out the double tangent formula, well, I could just say that the tangent of 2 theta is equal to the tangent of theta plus theta. And I have that formula for sum of tangent right there. I'm just going to think of this as my alpha and this is my beta. So when I do this first formula of sum of tangent right here, I'm going to get the tangent of alpha, which is the tangent of theta, plus the tangent of beta, which is the tangent of theta, all over 1 minus tan of alpha, which is theta, times the tangent of beta, which is theta. Oh, wow, I'm making all these fun rhymes. All right, so this is equal to 2 tan theta over 1 minus the tangent squared of theta. And there you go. That's your formula right there for double tangent, for a tangent of 2 theta, okay? All right, now using that formula, I'm going to rewrite it here. Tangent of 2 theta is equal to 2 tan theta. You guys, I know I'm going fast, but you can always slow down and rewind and all that good stuff. Okay, do I want to do this? Nah, I don't care about this. In all honesty, I don't care. I'm going to give you a couple problems in the homework to try the tangent. Give it a shot, okay? I don't care about this so much. I mean, here we go. I'm going to move on. I don't care about this. All right, do I care about this? Yes, I care about this. If you're going to do an equation like this, sine cosine equals with that, well, this is a little tricky, but think about it. If you multiplied both sides by 2, bingo, 2 sine theta cosine theta equals -1. Haha, where'd you see this before? Well, you saw it at the very beginning where we said that 2 sine theta cosine theta is equal to 2 sine of 2 theta. So I can turn this into the sine of 2 theta is equal to -1. And then you guys should remember how to do that, okay? I would go onto my unit circle. I would figure out where is it that my sine is equal to -1, and that's at 3 pi over 2. Okay, but that doesn't, theta doesn't equal that 2 pi over 2 theta equals that. So I'm just going to remind you how to do that. You're from there going to divide by 2 or multiply by 1/2. So you're going to get that theta is equal to 3 pi over 4. But again, what's the period for this? That's my omega, and we know the period is 2 pi over omega, okay? That comes out to be 2 pi over 2, which is just pi, but I want to go from 0 to 2 pi, so I have to add another period to that, and my period is pi. So I'm going to add another 4 pi over 4 pi to have a common denominator. Sorry, 4 pi over 4. And I am going to get that theta is equal to 7 pi over 4. So that's my second answer, okay? This one's a little tricky. I think you should try it. If you try it, put your answers down, and you can try it and put it in your homework answers, okay? All right, I am moving on to 7-6 part 2 notes. Okay, here I am going through this. I'm scrambling through this. I'm doing half angles now. All right, so in other words, I'm doing the sine of theta of alpha over 2, the cosine of alpha 2, and the tangent of alpha over 2. And those are the formulas that go with them, those half angles. So if I was going to do an example here, I want to do the cosine of 15 degrees. I don't know what the cosine of 15 degrees is, but I can use the half angle formula to get the exact value. I can turn this into the cosine of 30 degrees over 2, okay? So notice, in that case here, I'm going to use this formula, the cosine of alpha over 2 is equal to plus or minus, now this is a little tricky, 1 plus the cosine of alpha over 2, okay? Now, 30 over 2, okay? 30 over 2 is 15. So I just use my formula here. What's alpha in this case? Well, alpha in this case is going to be 30 degrees, right? So I need to go say that that's equal to plus or minus the square root of 1 plus the cosine of 30 all over 2, which is equal to plus or minus 1 plus, what's the cosine of 30? The cosine of 30 is rad 3 over 2. Okay, all over 2. You're going to keep going with this, plus or minus the square root of 1 plus, and now here, this is what I want to do. I want to get a common denominator. I'm going to make that a 2 over 2 plus rad 3 over 2, all of that over 2. That's going to be plus or minus the square root of 2 plus rad 3 over 2, all of that over 2. This is not fun, but I'm going to be very lenient on how you're doing this. Now, let me ask you something. If I'm asking for the cosine of 15 degrees, is that going to be positive or negative? Well, it's right here. I'm in quadrant 1, and the cosine is positive in quadrant 1, so let's get rid of that negative sign, okay? It's just going to be square root of, now watch what I'm going to do here. I have a complex fraction. I'm going to take 2 plus rad 3 over 2, I'm keeping changing and flipping. I'm going to get this, the square root of 2, I'm multiplying, 2 plus rad 3, all over 4. I could turn that into the square root of 2 plus rad 3, all of that over the square root of 4, which is equal to the square root of 2 plus rad 3 over 2. And you know what? That's as much as I need you to go with that. Okay? Little tricky, but that's how it works. Okay? You could try this one, the sine of negative 15 degrees. Just make sure you go ahead and use that formula for sine up here. Okay? All right. Moving on, this is our last example that I want to do here. I think I got to think about that. Okay, this is a little tricky. If I'm looking for the cosine, I'm telling you, I am giving you this fact that the cosine of alpha is negative 3/5, okay? And I want to know what the sine of alpha over 2 is. I'm telling you that that alpha is in between pi and 3 pi over 2, which means I'm in quadrant 3, right? Okay, so although, here's the thing, okay? This is the tricky part. If I did this formula for here, okay? I did that the sine is this one right here. It's plus or minus the square root of 1 minus cosine of alpha. So it's plus or minus the square root of 1 minus the cosine of alpha, all of that over 2, I believe. Let me just double check. I never remember these. So it's all over 2. Okay. All right, you ready? Here's the trickiest part, is coming up with the plus or minus, okay? Well, I know that theta is in quadrant 3, but I'm interested in what's theta over, where's theta over 2? Which means if I divide this by 2, and I divide this by 2, and then I divide this by 2, that means that theta over 2 is somewhere between pi over 2, and this, if I multiply this, would be 3 pi over 4. Okay? Think of where you are here. Here's pi over 2. Here's 3 pi over 4. I am not in quadrant 3 anymore. I'm in Q2. I'm like somewhere here. I am in Q2. And the sine in Q2 is positive. So we're going to get rid of that negative sign. So it's going to be a positive square root of 1 minus the cosine of alpha. Well, I just told you cosine of alpha is this. So it's going to be 1 minus a negative 3/5, so 1 plus 3/5, all of that over 2, which is equal to 5/5 plus 3/5, all over 2, which is equal to 8 over 5 over 2. We're going to do the old keep, change, and flip. So I get this. It's the square root of 8 over 10, which I'm going to break down into the square root of 8 over the square root of 10, which is equal to, when I do this out the top, 4/2 over the square root of 10. That equals 2 rad 2 over 10. I can cancel and cancel. Sorry, square root of 10. I can't cancel, sorry. That was a mistake. So 2 rad 2 over the square root of 10. All right, here's what we're going to do here. We're going to rationalize that. We're going to multiply by rad 10 over rad 10. Okay, and we're gonna get an answer of 2 rad 20 all over 10, which is equal to, well, watch, check it out, I can cancel that now. I get, sorry, I get, this is a 5, so I get rad 20, which I'm gonna turn into rad 4, rad 5, all over 5. So it's 2 rad 5 over 5. That is my final answer, okay? Let's look at the next one, cosine of alpha over 2. You guys can do that. It's just going to be following the half angle formula for cosine. Okay, tangent, we're going to put a little star next to that. That might be kind of like, for time's sake, just a bonus, okay? There's the formula for the tangent. It's tricky. All right, guys, that's all. Watch this video, do the homework, and I'll see you next class. Bye.